do to start this one? Anybody have an idea? What do you need to do to start this one? Sam?
Take the arc cosine of -0.6.
Okay, and can you use the reference angle like one of our familiar ones? Or, so you're gonna use your calculator to do that? Okay, so yes, so you're gonna first find your reference angle to get that value, okay?
Is there a reference angle for that?
Well, remember, reference angles are any angle between 0 and pi over 2. They're always the first quadrant angles. Reference angles are.
Yeah.
Or actually, I gotta be careful because this would not be in quadrant. Your reference angle would be, I guess I shouldn't say that. There is a reference angle for this.
But
It's not gonna
like
be,
a standard one.
yeah, right, it's not a standard
Okay.
one.
Okay,
Okay.
got it.
So you're gonna have to use your calculator to get this one. Did anybody do that?
2.21.
2.21?
Mm-hmm. I got 2.21.
Yeah, I did too.
It's
definitely not.
cosine of -0.6.
Yeah.
Oh, okay, so you did it,
Get your
and
life
Sam,
together.
did you get it now?
It's 126.
Whoa.
186 degrees.
Okay, so one of,
2.21 radians.
for now, let's all stick to the same thing so that we're in the, at least talking in the same language. That way we can check and see if we're doing it okay. Okay, so let's say in radians for now, unless it says otherwise. Okay, so in radians, it's 2.21-ish.
Mm-hmm.
Okay. Is everybody good with that? So, is this one gonna, is it gonna hit, is the cosine curve gonna hit this one, the one that's referenced to this one, any more times?
Does it hit it at all?
0.6, no. 0.6 is just
Well, what's the period of the cosine function?
So it's
What, 2 pi. So we still are gonna have plus 2 pi n. It's gonna hit this thing an infinite number of times. The one that's on the unit circle, -0.6 would be
it's just gonna be
somewhere over
positive
here.
2.21 and negative.
So this 2.21 is somewhere over here, and it's gonna, or wait, 2.21. This is pi over 2. Yes, this is pi. Pi is 3.14, so it's gonna be over here, and every 2 pi n, it's gonna keep hitting that, or going backwards, it's gonna keep hitting it, right? So if it's wanting all solutions, this is always gonna be part of what we're doing. But isn't there another? Is there another?
I don't really feel like the negative.
Now, -2.2, okay, so which quadrants is the cosine angle negative? Which quadrants, not the angle, which quadrants does the cosine give us an output of a negative? 2 and 3. So when you found 2.21, it was right here.
Yeah.
So where is the other one going to be? In quadrant 3. So how are we going to get there?
like going negative.
Okay, so if I go from here and back 2.21, would that give it to me?
Yes.
Yes.
Could you say 2.21 minus 2 pi n?
You could say plus or minus right there. But these are two different angles to start with. Okay, now you could also, figure out what that would be like. For example, to get from here to here, you go up this far from pi, so you could also go down that far from pi to get to that angle as well. How are you guys doing? Is your brain hurting?
Yes.
Lacey, how's your brain feel?
Good.
Yeah, good. Okay. All right.
Just like right here is like a little shot.
Okay, we're gonna do one more find all solutions before I change it up on you.
Don't we?
Yes, we do.
X equals negative pi over 4 plus pi n, and x equals 3 pi over 4 plus pi n.
Okay, now, just out of curiosity, did anybody else get this? What, Johanna?
Can't you just use one
Why?
since they're pi?
Okay, so let's just do this. So x is equal to the tan inverse of -1, right? So this is saying the tangent of what angle is equal to -1. Okay, now there's a couple things we're going to look at.
I wouldn't have thought about that, but yeah.
I'm just going to look at the tangent like this guy. You know,
But there are two.
you know,
But there are two solutions.
you know.
Two different places.
Okay, right? Do-do-do-do-do. Okay, so the one that she originally gave me is at negative pi over 4. Here's negative pi over 4. We go down, and that's -1. So now if I add negative pi over 4 plus a pi, just one pi, that's 4 pi over 4. What does that give me?
3 pi.
3 pi over 4. So, is her answer wrong? It's not wrong, but she doesn't need this one. Because what's the period of the tangent function? Pi. Now, and let's take a look at y. So the answer to this, I would just do one of these. Now, let's look at it on the unit circle. Okay, you guys, so you can, so we can talk about, excuse me about that. All right, so at negative pi over 4, it's right here. This is, the tangent is y over x, right, on the unit circle. So you have a negative divided by a positive. But up in this quadrant, the tangent is y over x, so you have a positive divided by a positive. And in this quadrant, going over here, you have a negative, oops, the y is positive. You have a positive divided by a negative. And in this one, you have a negative divided by a negative. So the result of this is positive, and the result of this is positive. So even though it does occur at two different places, since the tangent curve repeats itself every pi, you don't have to write both the starting points down on that one. Okay? So look at all this stuff that you're putting together right now. You're putting together periods, you're putting together where it is on the unit circle, you're putting together what the graphs look like. You're putting together a lot of stuff right now. I mean, this is a lot that your brain is like putting together right now. And that's why solving trig equations can be challenging. Not impossible, of course. Now, I haven't even gotten into any really interesting ones. So it's time to. So we're going to get to, I know we don't have that much time left, but we're going to get to a couple interesting trig equations.